This video will cover the topic, solving an equation with a root index greater than 2, problem type 1.
I don't think I understand the term root index. What is that?
Let's take a look at the cube root of 8. The 3 on the radical symbol is called the index of the radical. So the root index of a cube root is 3. Now let's look at the square root of 9. Although we don't typically write it out, the root index of a square root is 2. If we remember, taking the square root of a number and squaring a number are inverse operations.
Okay, I think that makes sense. So, what kinds of equations will we be solving?
Let's say we're given cube root of u equals 5, and we're told to solve for u. Since the root index is 3, we can isolate u by cubing both sides of the equation. This is because the inverse operation of taking the cube root of a variable is to raise that variable to the third power. 5 cubed is 125, so our final answer is u equals 125. We can check this answer by substituting 125 back into our original equation for u, and we see that the cube root of 125 equals 5, so we're left with 5 equals 5. Because this equation is true, this tells us that our determined solution is correct. Let's try another example. Say we're given the equation fourth root of y equals 2, and we're told to solve for y.
Okay, so since the root index is 4, we can raise both sides to the fourth power in order to isolate y, right?
Right. When we do this, we see that y equals 2 raised to the fourth power. 2 raised to the fourth power equals 16, so our answer is y equals 16.
Okay, so now we can check our answer by substituting 16 for y. And since the fourth root of 16 is 2, we know our solution is true.
Good job!
So to solve an equation with a root index greater than 2, we can first identify the value of the root index. We can then isolate our variable by raising both sides of the equation to a power equivalent to the value of the root index.
That's exactly right. Great work!